Well, thanks everyone for hopping on and being able to join this afternoon or morning or evening, depending on where you are out there. So my name is Pat O'Brien. I'm with the application engineering team here at aPriori. So today we'll be going over some of the reporting and dashboard capabilities within the tool, and really looking at the different ways that you can tap into all of the data that's able to come out of the aPriori system. All right, so let's imagine a different approach here. So what if your teams, specifically speaking, sourcing teams in this perspective, had the ability to identify really the optimal parts for requote and renegotiate? We don't want our teams spinning our wheels, kind of going down the path of finding parts that may or may not be appropriate or may not have the opportunity of a recost or requote point. Shifting gears to the engineering world, what if your engineering teams now had the ability to really pinpoint those ideal parts for redesign? Just as we mentioned before, really spending time on particular parts that are already optimized or that just don't have sort of that expansive ability to go in and pull cost out of those components. Really having a filter or a way to identify which parts are best suited for this. And then, this one applies to both your sourcing teams, or if you're in more of the quoting use case, really identifying manufacturing requirements for those bid packages. The example is you've got 10 or 15 parts. What is actually required from that supplier to generate a successful bid package there? Are they going to need 15,000 hours on a particular machining center that they just simply don't have? Being able to use some of the reporting capabilities here, we can actually pinpoint exactly which machines are going to be required and what the capacity requirements of those would be as well. And then finally, your VAVE teams. Just as all of these other ones here, we're really looking for the best and the parts that have the most opportunity available, right? Rather than grabbing that costed bill of material and sort of filtering through it and maybe just grabbing the most expensive item on the list. Well, chances are a lot of teams before them did the exact same thing. So having really the parts from either a percentage standpoint or understanding a dollar figure associated with how much money is really being left on the table with these particular parts. All right, so let's jump right into the platform. We'll show you what some of this looks like within the tool itself. So everything here is going to start with data. Within the aPriori platform, we generate a tremendous amount of data for each individual part that's pushed into the system and costed. So we can see here a quick snapshot of an individual part. We have very detailed manufacturing and routing information for this part, cycle time info, a detailed cost breakdown relative to this part, inclusive of that manufacturing process routing. All of the individual steps, whether or not there's any secondary operations that are happening along the way. And then finally, all the way down to that individual feature set. So the overall length, width, height of the part, the material, how many holes are found in this part, really all of those challenging or just standard type feature sets that are found within a particular component. So once we have data for these parts, it doesn't really do us any good to look at one single part in a reporting database, right? We want to compare parts. We want to look at multiple things maybe within an assembly, or alternatively, maybe the parts have nothing to do with one another other than the fact that they're in the same commodity group. So something like all of your 6061 machine components, or maybe all of your cold rolled 1020 sheet metal parts. Being able to organize these into a single unit, basically, to then compare these parts. Within aPriori, we call that a rollup. And that looks something like this here. So a rollup is really just a collection of data. So in this particular example, we've got a bunch of parts that we brought in. This is the example of looking at some of our machine 6061 parts. So a rollup can contain individual components. This can contain other rollups. It can contain assemblies. It's really just a bucket of parts or a bucket of data that we then want to compare later in our reporting database or reporting platform. So the next step here is once we have a rollup and we're ready to do some of those comparisons, this rollup is pushed out to that reporting database, and we're now able to tap into this individual rollup with any of the reports that we have within aPriori. So the reporting database, this may be a familiar screen for those of you who use Cost Insight Report today. If not, these are some of the out-of-the-box or standard reports that come with aPriori. You can see that there's a tremendous amount built into the platform right out of the get-go here. So there's a few that I do like to highlight just to show some of the capabilities and sort of how those teams can use things more use case specifically, as we had mentioned in that first slide that we touched on. So the first one that I really like to highlight here is a cost outlier identification report. So this report here, what we're effectively doing is taking that roll-up that we had within the aPriori platform, and we're now looking at what do you currently pay for these parts today, indicated by these darker blue bars here. We're then going to overlay that aPriori should cost. So we've done a full manufacturing assessment on these parts. We have those optimal routings identified. We have the material information in there. We have all of our tolerance data. So really, what should that part cost versus what you're paying today? And then we go ahead and just highlight basically a delta with these red lines here. So the top graph is representative of the actual dollar figures itself. So if we come over here to the left, this is where we're going to see the part with the most opportunity from a cost standpoint. We're seeing here a gap of about $19,000 annually. And then conversely, if we go over here to the right, we're going to see the polar opposite of that, right? This is where we're actually identifying that there's a gap in the opposite direction, meaning that generally speaking, you're getting a pretty solid deal on that particular component. And I will say I do a lot of workshops with a lot of clients. This is a very common output, what you're looking at on the screen here. And it is encouraging to see that, we do have a couple of parts over here on the right. We do like to see sort of a flatter middle ground on these graphs. That's indicating to the user that you're pretty well aligned with your supply base, but we're always going to see, about 10 to 15% of the dramatic outliers here on the left. And this example is really where your sourcing team now knows these are the 5 parts that are going to, most bang for our buck to go after. And, looking at that the exact same roll up and data set from a percentage standpoint on the bottom. So this is where this example I really like to point out for your VAVE teams. So rather than focusing on the actual dollar amounts, really looking at which parts here are the low hanging fruit, right? Where do we have some really large gaps from a percentage standpoint that are going to be easier to close than others, right? This particular part, we've got $3,800 available, but only a 3% should cost gap. Whereas the one next to it, we have less opportunity, but we've got a 36% gap. So while these numbers aren't, monumental, the example there is you're going to be able to squeeze a lot more out of a 36% delta than you will a 3% one there. So really highlighting where that low-hanging fruit is for your sourcing teams or for your VAVE teams to jump in and identify which parts are optimal there. Next up, more of the engineering use case here. So this is another out-of-the-box report. So something that is generated each time you cost a part with an aPriori is design feedback. So in this particular case here, we're looking at the design to cost feedback. And basically the way this graph reads is we go ahead and we neutralize the data set from a cost perspective. You can see this sort of standard deviation bars here, but then we're going to score these components as well. So we're actually going to assign them low, medium, high design to cost scores. And that's what we can see here in purple. Think of purple as bad. It means that part has multiple challenging manufacturing issues. And if you see a large purple bubble that's outside of this window, that's really indicating to the engineer that that right there is the part we want to focus on. It's more expensive than the other parts on average, and it has more design challenges. We're able to also look at the criteria that's being generated here to look and actually generate the colors of those bubbles. We can see exactly what we're assessing. So hard manufacturing issues, sharp corners, length to diameter ratios with end mills, as well as slow contouring operations, and then maybe non-standard tools or tolerances that are requiring specialized finishing. And finally, the last report that I like to showcase here, this is something that's actually out of our ad hoc reporting database. So this particular report is actually something that you can go in and generate on your own. So as we showed earlier, there's a tremendous amount of data in the system. Any one of those data points, you can go ahead and tap into that and then report on that. So this example here is actually looking at this bid package and understanding what machines are going to be required and what's the annual capacity that's required for those machines. So whether this is a sourcing team or someone on your quoting team that wants to understand really quickly, are we going to have a capacity constraint here? You know, we can see our 3-4 axis mill, no problem. We're at 260 hours and just under 1,000 hours. But we shift gears to look at this 5-axis machine, and holy smokes, we're over 9,000 hours there. So we're going to need some pretty substantial capacity, 1 shift, maybe 2 shifts. You know, get a machine running lights out to go ahead and help out with the increased capacity for this particular part, or the particular parts within that roll up. All right, so shifting back to this. So just in conclusion here, so as demonstrated, using the tool for your sourcing team, they really can identify where that low-hanging fruit is. Again, whether that's specific to an assembly or an individual product, or looking at things like an entire commodity group of parts. Engineering is able to quickly assess those manufacturability challenges, and they can do this at a macro level, right? You're able to look at multiple parts within that specific product line or that commodity group and understand which ones are lending themselves best for a redesign. Your quoting teams can identify the optimal suppliers and really understand quickly whether or not there's going to be bottlenecks associated with pushing out this new bid package. And your VAVE teams are really able to reduce your COGS faster and use aPriori as that fish finder. You know, dig in there, understand really rapidly and quickly which parts are going to be the most bang for the buck here for our team to actually go after on both redesign, requote, renegotiate. All right, and with that, if there's any questions, don't hesitate to, you can always ping me if you look at the meeting details here. You can feel free to set up either a private meeting with me on the Pathable site throughout the conference, or feel free to shoot me a quick email. My email address is right there, and then you should be able to see additional information in my profile as well. But thank you all for attending this session, and please hop around to some of the other ones. Should be rotating around every 15 minutes this morning. So hop into another one and grab some more info on the aPriori tool. Thanks. Have a good one.